You are watching to your favorite channel, Mr. Ask Me Anything. In this video series, I'm going to solve question number 1, Roman number 1 to 10 of exercise 1.4. If you want to watch preceding exercises, please click the I button or go to link given in description below. Okay, let me read the question first. Question number 1. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion of Roman number 1, 13 by 3125, Roman number 2, 17 by 8, Roman number 3, 64 by 455, Roman number 4, 15 by 1600, Roman number 5, 29 by 343, Roman number 6, 23 by 2 to the power 3, 5 to the power 2, Roman number 729 by 2 to the power 2, 5 to the power 7, 7 to the power 5, Roman number 8, 6 by 15, Roman number 9, 35 by 50, Roman number 10, 77 by 210. Okay, I'm going to solve Roman number 1, Roman number 2, Roman number 3, Roman number 7, Roman number 9. So before calculation, let us try to understand some basic concept of like terminating decimals. Let me write terminating decimal here. Let me give you the example of terminating decimal. Look carefully. Terminating decimals, see 0.25, 0.21, 0.132 and 1.65 and so on. Let me come to another type of decimal numbers. Say non-terminating. Let me write here non-terminating repeating decimal. Non-terminating repeating decimal. Let me give you example 0.25, 25, 25, 25 and so on. Another is that 0. Let me write here 0.21, 21, 21, 21 and so on. Another is here 0.132, 132, 132 and so on. Let me give you one more 1.65, 65, 65 and so on. Okay, let me come to another type of decimal again, that is called as a non-terminating and non-repeating decimal. You can also say non-terminating and non-recurring decimal. So let me write here non-terminating and non-repeating decimal. Let us see the example 0.25, 225, 225 and so on. Another is 0, 21, 211, 211, 211, 2 and so on. The last one is 0656, 556, 556 and so on. Let me write the number 1, number 2, number 3. See, all these three types are having different properties. That means they have a different patterns in the format of writing decimals. If you look, you will be seeing the difference. So as we are going to solve this question number 1 here, let us firstly define what is terminating decimal. That means a number given in a one type. The number given in a one type is a terminating decimal. So let me define here what is terminating decimal. So terminating decimal means in a number p by q. In a number p by q, if q has a factors of, that means the number at the denominator has a factor of 2 only, or having a factor of 2 to the power n, meaning that is 2 into 2, 2 into 2, 2 into 2. How many times you have to take? That means it should have only 2 factors. And in a second type, if the denominator, that is q, has a factor 5 only, or having a factor of 5 to the power n, the meaning of that is 5 into 5, 5 into 5 many times. Maybe it may be 3 times or maybe it may be 4 times. And in a third type, if the denominator q has a factor of 2 and 5 at any factors, maybe like 2 to the power n into 5 to the power n. That means 2 into 2, 2 into 2 and into 5 into 5 into 5. What actually it means is that if the denominator q has a factor of 2 or has a factor of 5 or having a factor of both 2 and 5 in any numbers, then in any numbers means in any factors. That means that should have only 2 and 5 factors. Then such type of number can have a decimal expansion. Listen carefully. And if q has factors other than mentioned above, then p by q is non-terminating repeating decimal. To make the questions more easier, let us see the examples. Let me write some numbers. for your more clarity. So let us see the example here. Let me write, let us see the examples. So let me give you some types of number. 13 divided by 5, and let us say 13 divided by 2, 13 divided by 6, 13 divided by 10, and finally 26 divided by 25. Actually, for this question we don't require any division, but let us see the division how it is. So let me have a division, that 13 divided by 5, you can divide this very easy. 5 2 are 10, remainder is 3 here. Let me put point here and bring 0 here. That means 5 6 are 30. So 2.6 we get it here. So 2.6, that is terminating decimals. Now let us look to 13 by 2. 13 divided by 2. 2 6 are 12. 1 is the remainder. Let us keep point and let us bring 0 here. 2 5 are 10. So 5 also, 2 also has a terminating decimal. But let us see a different number, that is 6. 13 divided by 6. Let us see. That is 6. 2 are 12. Remainder is 1. Point, you bring 0. 6 1 is 6. 4 is the remainder. Now bring 0 as because of that point. Now 6 6 are 36. Again similar remainder, that is again 6 6 36. Again similar remainder, bring 0. 6 6 36. So it continues like this. Now as 6 is different than 5 and 2, we get this 2.1666 and it continues. But let us try 13 divided by 10. 10 1 is 10. 3 is the remainder. Bring 0 here after point, then 10 3 30. Now 10 is equal to 2 into 5, that is a criteria of terminating decimal. And 6 is equal to 2 into 3, that is not a criteria of terminating decimal. So it is different. Now that is 13 by 10. Now let us see 26 divided by 25. So you know that 25 into 1 will give you 25. Here remainder is 1 and 0, that is after point you will bring 0. But here 10 is smaller than 25, so you have to write one more 100 after putting 0 at that after decimals. Now let us go by 4. 25 into 4 is equal to 100. You get it this. Now see here 25 is equal to 5 into 5. 5 2 and 10 and 25, they have a factors which is satisfying for this and this. 4 numbers are terminating decimal. But if you look this 13 divided by 6, that is different, is it is not satisfying the condition which I have defined here. So it will be a non-terminating repeating decimals. As the question never stops, it should be non-terminating repeating decimals. Okay, based on this concept, let us try to solve the problem. It will be more easier. So let us look this Roman number 1, 13 divided by 3125. I will illustrate it, but you need to remember the fact which I have already defined you. So solution Roman number 1. Solution Roman number 1, let me write here 13 divided by 3125. So again let me write here 13 divided by 3125. I have already taught you how to take the LCM. So let us take the LCM of 3125. When you take LCM, you have to go by 5, and this is 5 6 2 5. That is 5 6 are 30, 5 2 are 10, and 5 5 are 25. That means 5 6 2 5 is 3125. Now let us go by 5. 5 1 2 5 is 625, and let us go by 5. 5 25 is 125. Again let us go by 5. That is 5 5 25. Let us go by 5. 5 1 is 5. So now here as denominator that is 3125. As denominator 3125 is equal to how many 5? There are, let us count the number here, 1 2 3 4 5. That means 5 to the power 5. I have taught you that P by Q, suppose for example Q, that is denominator, has a factor 5 to the power n, or 2 to the power n, or both 5 to the power n, 2 to the power n. If Q is satisfying these three conditions, that is terminating decimal. So that is terminating decimal. So here Q satisfy all these factors 5, 2 and 5 into 2, then it becomes a terminating decimals. Likewise here 3125 to the power 5 has all the factors 5. So 13 by 3125 will have a terminating decimal expansion. Now let us come to Roman number 2. Let us have a look to the question. Roman number 2 question, it is 17 by 8. So let us solve. Roman number 2, let us write here 17 by 8. Now let us write once more again this 17 by 8 here. 17 by 8. You know that as denominator, you know denominators, not it? Denominator means number at below. As denominator, 8 equal to 2 to the power 3. Let us check by LCM. So at this 8 not nice, let us cut. So 2 4 are 8, 2 2 are 4, 2 1 is 2. So we have 2 to the power 3. Then let us write this 17 by 8 will have a terminating decimal expansion. Let us try to solve Roman number 3, that is 64 by 455. Let me write Roman number 3 here. 64 455, that is 455. Let me write 64, and this 455 is equal to 5 into 7. 35 into 13 is 455. Let us look the LCM here. 4 5. Actually you have to find the LCM first. Yes, I know this number I had written here, but you have to take LCM first. So 591 is equal to 455, and 7 into 13 is 91, and 13 into 1 is 13. So we get that one. Now what we have to write here is 57 into 13. So that is the denominator 455. As the denominator 455 is equal to 5 into 7 into 13. This one we get after LCM. 64 by 455 will have non-terminating repeating decimal, unlike to the previous question, because there is no factors of 2 and 5 only. As I told you, p by q, where q should has a factor of 2 to the power n, or 5 to the power n, or 5 into the power n and to the power n. Here this is different than these conditions. That is why this 64 by 455 will have non-terminating repeating decimal expansion. Now let me come to Roman number 7, that is a denominator 2 to the power 2, 5 to the power 7, 7 to the power 5, and as well as 35 by 50. Let me solve this Roman number 7 and 9. So let me keep this aside, and then let's come to Roman number 7. Let's come to Roman number 7, that is 129 by 2 to the power 2, 5 to the power 7, 7 to the power 5 is equal to 129. Let us keep in a factor form, 2 to the power 2 into 5 to the power 7 into 7 to the power 5. So as similar with other, as denominator is equal to 2 to the power 2 into 5 to the power 7 into 7 to the power 5. Therefore 129 by 2 to the power 2, 5 to the power 7, 7 to the power 5 will have a non-terminating repeating decimal expansion. Now let me come to the last question of this video series, that is Roman number 9, 35 by 50. So listen to me carefully. Let me solve this problem. Roman number 9, let me write first 35 by 50. It is similar with those questions which I have already calculated before. So let us take the LCM of 50 here. 225 is 50, you know, and next you go 5 are 25, and then again you go by 5 1 is 5. So this p by q, as I explained you, q should have a factor of 2 to the power n, or 5 to the power n, or 2 to the power n into 5 to the power n for terminating decimals. Now as it has 2 to the 255, that means 35 50 is equal to 2 into 5 to the power 2. That means it is satisfying the condition of terminating decimal. So we will write here terminating decimal. Now as 50 is equal to 2 into 5 to the power 2, that is as denominator, what is denominator here? 50. 50 is equal to 2 into 5 to the power n. So 35 by 50 will have a terminating decimal expansion. Rest of the questions which I haven't solved, you try yourself and submit to me in my Gmail account, that is ristenneon1986@gmail.com. Dear children, do not hesitate to put me a questions whenever you have a problem. You can send me a questions to my Gmail account, or you can put a question to a comment below. I am always ready to solve your problem. Thank you for watching Ask Me Anything, and I am signing out for this video series. See you in my next video. Till then, take care. Thank you for watching Ask Me Anything. Please do like, share and subscribe to support my channel Ask Me Anything. Your one subscribe will give me a new platform of teaching. If already subscribed, then thanks for your subscription. And press the bell icon to get interesting questions and latest updates.